Let me start by recalling the scene. A small creature bursts out of a crew member's chest, causing massive trauma and death. The user wants to know if this is possible in real biology. First, I should consider human anatomy. The chest cavity contains vital organs like the heart, lungs, major blood vessels. A creature growing there would need space. Where would it get the nutrients? In humans, a growing fetus is supported by the placenta, but an alien embryo would need a similar system. However, in the movie, the gestation period seems very short, maybe days, unlike human pregnancy. That rapid growth would require massive energy, which might not be feasible. Next, the size of the chestburster. It's shown to be about the size of a small animal. The human body doesn't have space for that without displacing organs. The pressure from such a creature would cause organ failure, internal bleeding. The host would die long before the creature could burst out. Also, the force needed to break through the ribcage. Human ribs are sturdy. How would a small creature muster that force? Maybe if it had sharp appendages or acidic blood to weaken bones, as in the movie. Wait, in the movie, the alien has acidic blood. Maybe that's a factor. The chestburster could secrete acid to dissolve the ribcage, making it easier to escape. That might explain how it breaks through. But acid inside the host would cause severe burns and toxicity, possibly killing the host sooner. The movie shows the host alive until the burst, which might not align with real biology. Another angle, alien biology differences. Maybe the alien embryo doesn't rely on the host's nutrients in the same way. Perhaps it's a parasite that can generate its own energy or has a different metabolic system. Some real-life parasites manipulate host behavior, but none grow to that size. Maybe the alien uses the host for protection rather than nutrition, but that doesn't solve the space issue. The user mentioned theories on alien biology. Could the alien have a different method of growth, like being able to compress its body, or exist in a larval form that expands rapidly upon emergence? Some organisms can undergo rapid expansion when they hatch, like certain insects or amphibians. But scaling that up to a creature the size shown in the movie might not be feasible. Also, consider the host's immune system. A foreign organism growing inside would trigger an immune response. The alien would need to evade or suppress the immune system. Some parasites do this, but again, the scale here is much larger. Maybe the alien has biological mechanisms to cloak itself or neutralize the host's defenses. Another point, the chestburster's exit. In humans, the diaphragm and muscles would be a barrier. If the creature emerges through the sternum, which is bone, it would need to break through. Acidic blood might help, but as mentioned, that would cause other issues. Alternatively, maybe the creature uses enzymes to weaken connective tissues rather than bone, but the ribs are still in the way. I should also think about real-life examples. The closest might be parasitoid wasps that lay eggs in hosts, and the larvae eat their way out. But those are much smaller, and the hosts are insects. The scale difference is enormous. Translating that to a human host and a large creature isn't directly comparable. Energy requirements. For the chestburster to grow that quickly, it would need an enormous amount of energy. Human bodies can't provide that in such a short time. Maybe the alien has a different metabolic rate or uses alternative energy sources like radiation or inorganic compounds, but that's speculative. Structural support in the host. If the alien's body is more flexible or has a different skeletal structure, it might fold itself into a smaller space. But even so, the host's organs would be compressed, leading to death before the emergence. In the movie, the host seems relatively healthy until the bursting. In reality, the host would likely experience severe pain, internal damage, and die from shock or organ failure long before the chestburster emerges. The scene is dramatic but not plausible biologically as we understand it. To make it theoretically possible, we'd have to imagine alien biology with traits like rapid growth using external energy sources, acid secretion to breach bones, immune evasion, and perhaps a method to keep the host alive despite massive internal trauma. Maybe the alien secretes painkillers or stimulants to keep the host functional until emergence. Or the alien's biology is so different that it doesn't require the same space or nutrients as Earth organisms. In conclusion, while the chestburster scene is iconic, it's biologically implausible by Earth standards. However, speculative alien biology with unique adaptations could theoretically make it possible, though highly unlikely based on our current understanding.